I would like to start saying that we are happy, we're glad to be a part of the ALTE community. There's a lot to attend this evening in this event. I have about 20 slides to briefly summarize 3 different statistical procedures that we are working on to enhance the fairness of Turkish proficiency exam, which I refer to TYS. So Mehmet, my colleague, and I are working on this. He's actually back to the United States, and he's now working for New Jersey Institute of Technology. I work at the University, Izmir, Turkey. We're still trying to help the Institute to increase the standards, and we are also trying to answer some research questions together. So today I will try to briefly explain some of those. You can go next. So before I start, I would like to give you some information about Turkish proficiency exam. It has been administered since 2013, takes place 3 times a year. So before the pandemic, the number of test takers and test centers worldwide had been increasing due to the demand for learning the Turkish language. And in 2019, more than 2,000 individuals took the exam in 44 different centers located in 39 different countries. So the TYS has been audited exactly a year ago, back in April 2020. We received 14 GPs. So we're still working on 2 action plans. Actually, one of them completed, and the second one is ongoing. Separate than those, we're also trying to develop a computer-adapted test environment to efficiently assess basic Turkish language skills. Next, please. So in this presentation, I will briefly mention 3 statistical procedures. I like to abbreviate it as SP that are applied to the reading section of TYS. So the first procedure is an application of different differential item functioning and measurement invariance with binary data. The second procedure is a potential strategy to detect cheating, as a problem due to the key time, because we have many centers around the world. We administered tests in Japan and also in the United States. So I will share briefly about our attempts to locate excessive similarities in test takers' response patterns. And the third procedure that I will briefly mention is a comparison of different test-free measurement procedures for the reading section. So next, please. By the way, I don't see the time. So if you can give me update, if you can give me a heads up if I'm running slow, that'd be appreciated. So the first procedure is to detect possible bias. So our aim is to detect possible bias on the reading section. So traditionally, bias has generally been examined with respect to the demographic factors such as gender and social class in order to assure the test fairness. These are commonly studied factors, let's say. However, only 5 studies have investigated the item bias on different language groups in the language proficiency test. Next, please. So, next slide, please. So, the previous research was actually completed by Mehmet and presented back in 2017 with Nursel. They basically tried to use IRT procedures to detect TIF, detect differential item functioning. So we can skip the next one. We can go back to this if you have any questions. So the idea was to investigate 2 groups titled as Turkic language family group versus non-Turkic language family groups group. So the Turkic language group included those who speak Azerbaijani, Kazakh, Turkmen, Uzbek, Uyghur, and Tatar language, and the other first languages are categorized as non-Turkic family language. So the aim was to test if there is a bias for these 2 groups. So next one, please. Next slide, please. So we can go back one slide. All right. For the previous research, there were 27 different first languages. Several different diff detection procedures were employed, and the methods agreed that 2 items were showing diff. But back in 2017, the source of bias was not examined in detail. This was an explanatory work. So we kept investigating this diff. We can go to the next one, please. So the previous research used IRT framework to detect diff. So for the current research, we used the SCM framework, and we used the 2019 May data. So responses for reading B2 items from 789 individuals are analyzed. So single factor, confirmatory factor analysis revealed a good model fit. So Turkic language family group 631 individuals. The other group included 158 individuals. So we first run separate confirmatory factor analysis with binary data, and it corresponds to 2PL IRT. So after these CFAs, we used Raykov measurement procedures to test measurement invariance for binary data. We used M plus 8.5. Next one, please. So we can go back to this slide if you have any questions. The point is the single factor CFA fit the data satisfactorily. Can you go to the next one, please? So when we use the Raykov procedures, we saw that there is an item that had significantly different threshold values for 2 different groups. So we used BIC to decide if there is a meaningful difference between the model we have and the baseline model. So the SCM framework flagged item 24, and the Lord chi-squared method also flagged 4 items, and number 24 was one of them. So next one, please. This is the item 24. What we noticed that there is this idiom in the question, which is kol kanat germek. So apparently this question was controlling for the ability level. This question was harder for the non-Turkic family group. So when we investigated this idiom with our language experts, we saw that Azerbaijani language has kol kanat vermek, and Kazakh language has kon kanat, and the Turkmen language also has ganat aslan almak. These are similar idioms that we all have. Next one, please. Still waiting on the next slide. All right. So the findings from the previous and current research, specifically the items were examined by the content experts, including researchers and item writers who can speak both Turkish and Turkic language, such as Azerbaijani. It was found that the common use of proverbs in both languages could benefit the examiners whose first language was from one of the Turkic languages. And we will run one more test with our next administration, and then we will have language experts to discuss this, and then we might be able to publish these results. So next one, please. The second procedure that we tried, we're using, is to detect excessive similarities. Again, this is due to the key time issue. You probably are familiar with this problem. The goal is to identify pairs of students with response patterns too similar to have occurred from random chance alone. The goal requires to estimate the probability that student J answers item I correctly. So this procedure was developed by Veselovsky back in 2010, and it was implemented in R by Doran in 2010. Sorry if the procedure was developed back in 2000, and it was implemented back in 2010. So there's a really nice example on how it works. I dropped the link here so I can share the presentation. If you want to have it, we can look at it together. So in our analysis, we treat each administration as a single class. So each participants were treated as a single classroom. So we try to detect the excessive similarities. So I will share some example cases. Next one, please. So the code works like this. It flags the pairs that show excessive similarities. Like in this case, student 361 and 362 were flagged by the code. So the next step is to look at the responses. If there are more than two pairs, if there are more than one pair, sorry, it will show up here. So there might be more than 10 pairs flagged as excessive similarity. Next one, please. So in this case, when we checked the raw data, what we saw, the responses were identical for these two students. That was concerning. So we next one, please. So we went to the next step to look to check which IDs are those. So and then we noticed in this case that was a technical error by the scatter machine. It somehow read the same form twice. So this was a false alarm. But we had other cases showing similarities, and we did further investigations. So next one, please. The last procedure I'll briefly talk about tries to answer this question. More than 1,000 students took a multiple choice B2 level reading proficiency test. The test has 4 reading passages and 28 items. Each item has 4 choices. How should we score this test? So there are several different approaches to test to calculate the score. The first one is just compute the sum score, giving equal weights to all items. The second procedure we try to compute the total scores is the the conventional factor scores, confirmatory conventional factor analysis, CFA, which a general factor is defined by 28 binary variables. This model corresponds to 2PL IRT. The second M+ method uses a second order score, which first defines the passages as latent factors and then defines the second order general reading factor using these sub-factors. The third one is the M+ bifactor structure factor scores, which is also first defines the passage as latent factors and then defines a general factor. So we also investigated M+ 1PL model and also M+ 3PL model. So we also computed scores using Rush, based on the R LTM package. So another one is the Rush 1PL, and 2PL and 3PL models using the EIP estimation, and we also tested the empirical bias EB estimates for these models. Next one, please. So we're trying to understand what happens if we use these different alternative scoring procedures. So the first column shows the scoring method. The second column shows the how many candidates passed the exam if the cut score is the mean score. So the third column shows how many candidates passed the exam if the cut score set to be 60. and the scores are rescaled to 0 to 100. And the next column shows what happens if the cut score is 70 for scores rescaled from 0 to 100. The next one uses 60 as the cut score, and it rescales the scores to have a mean of 77 and a standard deviation of 18, which are based on the early results we have and treated as population values. And the last one also uses 70 as the cut score. So you can see the blue colors gives almost identical results, which are 1 PL by M plus, 1 P rush model with EAP, 1 PL with EAP, and with EV. Also, 2 PL as expected models give similar results to CFA, conventional factor analysis, and 3 PL models, different approaches, behave similarly. So the red ones shows the least amount of certified numbers, and the bold one shows the largest amount. So what we saw with these different scoring scenarios, the sum score, the conventional sum score approach is the most lenient and scoring procedure that the more participants are awarded with the certificates. So we're trying to understand how they differ, how they work similarly. So beside the conventional sum score, the remaining methods are considered as measurement-free procedures that are supposed to be independent of the group characteristics and independent from the item characteristics, the scores. So we are still working on this, but at the moment, it seems like the sum scores is the most aligned scoring procedure. So I think I completed in a timely manner. So next slide, please. I would like to thank you again, and I'm happy to take any questions. You can also email me. You can email Mehmet about those, especially IRT framework related questions. And I will also be around to answer any questions.